Hello and welcome back to my workshop. We'll crack on then, we'll cut this piece out. So now you can see that the 1690 machine, CNC Router that is capable of, or more than capable of cutting aluminium. Obviously, I will mention again that my particular machine is modified; it is not standard. That's why I can successfully get a finish as good as this. So in actual fact, I've taken this now over to the my manual lathe, and I've countersunk the holes that are necessary, and I've cut this one on the CNC Router, and I've countersunk the holes on that one too. I mean, they're absolutely perfect. I don't see any reason now why they won't fit the machine. So what I did actually on the manual lathe, because I forgot to write a program for it, I cut a slot in here for the pin rod to go in to lock the drive shaft up. But you know, when you want to change a tool, but it's left it a bit thin. So I think what I'm going to do for the production, bear in mind this is a prototype, and this is 9mm thick plate. What I'm going to do is I'm going to take this base plate up to 12mm, and I'm going to drill a hole through here because it's just left it a bit thin. I don't particularly like that. Not everybody is really gentle with these machines, so I try to make it sort of really butch and, well, what I would call idiot proof, I suppose. So there you go. I suppose the next job now is to well, I think what I'll do is I'll turn up the two risers here that I want to put here, risers, because you have to step this out now like this, and I got some 1" or 25mm bar stock that I can do that out of quickly, and but I got some 90mm bar stock. That's quite expensive stuff actually, bought here in Australia. So I'm going to now turn up the pulleys. Now I don't know, I'll film a little bit of that, but you know, I don't want to bore you too much. So I'll just film a little bit of the, you know, the roughing out to make a pulley. It's a pretty simple job on a manual lathe. I probably won't film it all, but I'll show you something about it, because I really want to crack on and get this up onto the tube for the weekend for you. And I want to show you the completed prototype kit. So I'm anxious to see that myself. So, but judging by what I've made so far, I think it's going to turn out pretty good. Bar, this needs to be about 12 mil, I think. So that'll be just a small adjustment. Okay, so we'll get on. Just change the tip around in my cutting tool because it was cutting a little bit, well, not quite as it should. So there we go. Okay, well, I'm back off the lathe and the manual milling machine, and I've finished my pulleys. Now, unfortunately, I think I only got about 30 minutes or so of footage in, and I didn't notice that my CAD was full in the camera. So anyway, we got there in the end. Also, I took the gear off the end of this little. Can you see that? I think you might be able to. The gear off the end of the motor here. Now I'm not sure whether it should be a press fit, but it was blooming tight. So what I had to do in the end was I got an angle grinder with a slitting disc in it, and very quietly just cut through the gear like that. But you've got to be careful that you don't transmit any heat into the shaft, because the end cover of that is plastic. So you've got to be very careful doing that. But it's the best way I could come up with to get that gear off, because it was really on there. So that's what I did anyway. So you may have a different method. You may have a small puller to pull it off, but I just got a slitting disc and just very, very quietly cut through him, and it just popped off with a pair of pliers. So just keep that in mind when you're changing it over. I'm sorry if I look a little bit sort of overexposed with light, but I like plenty of light in my workshop to be able to see. And actually when I'm videoing stuff down here, it comes up a lot better on the camera. So there we go. Enough of that now. So what I'm going to do, my first job, is to assemble this plate and this little pulley onto this motor. And incidentally, I'll supply all the obviously all the nuts and all the little screws, all the little Allen screws that are required for this kit as well. So because the ones that came off the motor, they're okay, but These are much nicer. Now we've made this hole so this will fit through it. So what you need to do is put this onto the okay, so having got your, I'm going to put that down. Yeah, just having got your pulley on, you just, next job is to put this plate on, motor plate. Just put them all in loosely first, then you can tighten them up. Just nip them all first, make sure you've got the plate on there nice and square. You can lock him up a bit tighter. I don't think it's necessary to put Loctite on it or anything like that. Just nice and firm. Make sure that motor turns freely, not fouling anything. And pretty well that's the motor side of it taken care of. Okay, now we're at the stage where we can put all this together. So the first thing I want to do is I've actually cleaned the key up a bit off the top here, and we'll put him back in. We need a little. Yeah, it's easier to get this this keyway back in now before I put the plate on. And you know, this is 9mm thick, and the production unit is going to be 12mm. So yes, it would be a lot easier to get him in there before you put this back on. So we've cleaned him up, and I just want to put him in here. So just put him in the bottom. Very, very gentle tap, that's all it needs. I just want to trial fit this on. Yeah, that's fine. Perfect, actually. Okay, so what I'm going to do now is this is the post that I've made. And so we'll screw all this together now. So I got two of these, one for either side of this, and we'll get him on. Well, one thing you will notice if you're using, when you're using a CNC router to machine something like aluminium, I don't know whether the light's picking that up, but you will get some chatter there like that. When the machine is moving in the Y direction, when it's moving in the X direction, it doesn't seem to be quite as noticeable, but certainly in the Y direction, you know, this, you know, well, it's a pretty good damn finish, but well, there you go. So I'll put this together, and then we'll screw it on the top here. Okay, so making sure all the dust particles, now to take it off. I'm going to give this machine a damn good cleaning actually. And this morning I actually received all my stepper motors and everything necessary to do the CNC conversion on this, so we're going to get straight into that. So it's going to take me about a week, I think, to work everything out and machine everything up, but that'll be the next series of videos. But we'll get this operating on here for now. Incidentally, what I've decided to, because now this is the following day from when you last saw this, I think I said that this is going to be 12mm. There's a good reason for that. Well, I actually forgot to program this into the CNC, so I cut that on my manual milling machine over there, and when I'd finished, it was a bit thin. So that's one reason why I'm going to go to 12mm instead of 9. And the second thing is I'm going to pre-drill this because I intend to manufacture and have available a tool changing air operated cylinder up here, or a manual type one with a lever. So there's going to be two types. So I'm going to pre-drill this, so all you have to do is screw it onto this, not have to bore holes and thread them into this. You know, the 12mm of aluminium plate, I think, is going to be very robust to be able to do that. It's only a little machine after all, and something like, I think probably about 25 kilo of pressure is going to be more than enough to keep an arbor in there. So okay, let's get on and get this in. That's on there pretty solid. So the next thing to go on is this. Well, that's pretty good as well. That's okay. And then this. So a bit of a burr on there or something. Oh no, he's going up. Okay, so when you've got him down snug, now how I get this down, just gently grip the shaft down here, not enough to mark it or anything, and just use one of these. Don't forget it's a left-hand thread. And then when you get it to that stage, when it's firm, you just get your brass punch or drift and just tap it, just like that. And that is enough. You don't want to do it any more than that, because you put extra load on the bearings that you don't want. And you just nip that up firmly. You don't have to over tighten it, so catch hold of it by the small end, right? And just firm with a couple of fingers, very firm, otherwise you start damaging the thread. Okay, so that's that. We're nearly there actually. So we're going to put this on first, because otherwise I'm going to forget it. And then we get our motor. Okay, so next we put our motor on. Now, let's have a look. That should all fit, I think. Hopefully. Just nip that one for a second. so tight so I can't move the motor. Get this out of here. If you unscrew the back of this little lock-in mechanism and take him apart, so you notice there's like a gear-toothed cap on him. Well, that's what engages the little arm on the inside, but it's easier to take the little arm off and put the washer on and stick him in there and wind him down with your fingers, otherwise you're going to be quite some time trying to get it on. And then get the little arm, put back on, and screw the screw in the back. Like that. Okay, now you don't have to over tighten these belts, just put your thumb on it and just tighten him up a little bit like that, and then lock this down. That belt doesn't have to be really tight. This is only a little 300-watt motor, and just no need to have it too tight. Where's an Allen key? I'm always putting stuff down and losing it immediately. About there, I think. Well, that seems to all work all right. I actually did I did actually fit this up before I came on camera to make sure that it all went together all right. Look, just a little bit of fettling here and there, and I did have to rebore the center of this this large pulley out. I'm going to be honest with you, because it was just too tight to fit on that shaft. So anyway, so I'll get this electrical box on now and we'll fire it up. Let me turn this round so you can get a better look. So there it is. Running pretty quiet as well. That's the slow speed. And let's see about changing speed. Okay. Well, that's pretty quiet as well. That's probably about 4,500 RPM. Because this motor runs at 6,000 RPM, and the ratio that I've worked out that makes this this output shaft then, or drive shaft, operating about 4,500 revs or thereabouts. Thank you for watching this video, and I hope it'll create some interest for you. And if you've liked the video, please press like or subscribe to my channel. And if you press the little red box down there that Google has kindly provided for me, you press on that, and that will take you to my YouTube channel, where there's now close to 130 videos of CNC routing. I do a lot of wood turning, and a little bit of lathe work, and a little bit of computer work, and ArtCAM. And incidentally, a lot of you are asking me how I put the three-dimensional pictures together and cut on the CNC router. I have two ArtCAM programs. One of them is ArtCAM Express, 2015, and the other one is ArtCAM Jewelsmith. That one gives me the rotary axis and gives me the ability to actually make a 3D picture myself. There's a couple of videos that I've done out showing you how to do that from a grayscale picture. So the next video that I'll be doing will be starting to measure up and manufacture the kit to convert this little X3 to full CNC. So thank you for watching, and bye for now.